Assalamualaikum warahmatullah. My name is Ali B-Boy. Doing a presentation on computer engineering, chapter 5, networking concept. And this chapter covers networking protocol, standard, and services. Networking concept, section 5.2, information technology, course computer engineering, group 5, a name and my student number. We first begin with the definition of networking protocol, standard, and services. Networking protocols are a set of established rules that dictate how to format, transit, and receive data so computer network devices from servers, routers, endpoint can communicate regardless of differences in their underlying infrastructure and design or standards. What is this trying to explain is that for computers or any end device to communicate, they need a protocols. And those protocols govern the rules. For example, if two computers need to communicate, they either need physically connecting cable or wireless. And even after connecting the wireless, you have to have IP address configured on both the both clients so that they can communicate with each other. Standardized network protocols provide a common language for network devices. Without them, computers wouldn't know how to engage with each other. As a result, respect for specialty network built around a specific architecture. Few networks will be able to function, and the internet, as we know, it wouldn't exist. Virtually, all network end users rely on network protocols and standards. As I said before, these protocols are the rules that govern the network so that they can communicate. In computer networking, a network service is an application running the network application layer and above that provide data storage, manipulation, presentation, communication, and other capabilities, which is often implemented using a client-server peer-to-peer architecture based on application layer network. These services are the programs that runs in the computer, for example, email, file server, and other applications that runs on the computer. Those are the services. Transport layer protocols. Network communication involves a suite of protocols known as Internet Protocol, or more commonly known as TCP/IP protocol suite. This protocol suite includes all the protocols used in various aspects of end-to-end network communication, including addressing and routing. TCP/IP protocol suite, like for computers to do routing and reachability, you must have an IP address configured in both the end devices. Without IP address, there is no way computers can communicate to each other. TCP/IP protocol suite is also conceptual model that classify and organize the various protocols into 4 different layers. The layers are network access, internet, transport, and application. These are the 4 TCP/IP protocol suite. The protocol layer, transport layer includes 2 protocols: the TCP as the transmission control protocol and the UDP user data protocol. This protocol determines how the data will be delivered reliably or unreliably. It is up to the network application to choose. For data to reach from source to destination, is either you must use either TCP or UDP. TCP or UDP, reliable or unreliable. So it's up to the data to choose whether it should be TCP or UDP. In summarization, The applications such as those that perform file transfer, downloading web page, and email, all use a reliable transport protocol, whereas UDP is used for applications such as real-time video, voice, where speed is more important than reliability. Yes, that is downloading. We all know that website, web page, like website, email, all those things, you need something that is reliable and secure. For an UDP, voice over IP, those are real-time thing, and it needs a very important reachability. In voice protocol, reachability is always a priority. Still, TCP/IP models. The TCP/IP model consists of layers that perform functions necessary to prepare data for transmission over the network. TCP/IP standard stand for two important protocols in the model: transmission control protocol, that's the TCP, and Internet Protocol IP. TCP is responsible for tracking all the network connection between a user device and multiple destinations. The Internet Protocol is responsible for adding addresses so that data can be routed to the intended destination. Yes, without IP address, there is no way you can route your data to destination. There is no way the data can come from the source to the destination. IP is very important in networking. Without IP, there is no networking. The two protocols that operate at the transport layer are TCP and User Data Protocol, UDP. So in figure 1, the next chapter, TCP is considered as reliable, full-feature transport layer protocol, which ensure that all the data arrive at the destination. In contrast, UDP is a very simple transport layer protocol that does not provide a reliability. Figure 1 will give you an explanation of TCP and UDP. As you can see, this is an email server. We all know that email is very important. Reliability is important. Acknowledgement, receiver to receive it. Resend lost data. In any email, there must be no any lost data. It's very important to deliver to the destination. UDP, IP telephony and live streaming. Fast, because voice, you need something very fast, low overhead. There is no like latency. Need 100% latency, at least 95. Does not require acknowledgement. Does not present lost data. Deliver data as it arrives. TCP helps to determine how a specific computer should be connected to the internet and how you can transmit data between them. It helps you to create a virtual network when multiple computer networks are connected. TCP stands for Transmission Control Protocol, Internet Protocol. It is specifically designed as a model to offer highly reliable and end-to-end byte stream over an unreliable internet network. UDP is a datagram-oriented protocol. It is used for broadcast and multicast type of network transmission. The full form of UDP is User Datagram Protocol. The datagram is a transfer of unit associated with a packet switch of network. The UDP protocol works almost similar to TCP, but it throws all the error checking stuff out, all the back and forth communication and deliverability. Application and port numbers. TCP and UDP use source and destination port number to keep track of application conversation. Every network application is identified by a transport protocol using a well-known port number. The source port number is associated with the application that oriented the request, known as the client computer. The destination port number usually is a well-known port number associated with the destination application on the remote device, server, computer. Port numbers are very important in networking. Like in every communication, there should be a source and destination port. There are ports known as well-known ports, registered ports, dynamic and private ports. Port numbers ranging from 0 to 1023 are known as well-known ports. Port numbers ranging from 1024 to 49,151 are known as registered port. Port numbers ranging from 49,152 to 65535 are dynamic or private ports. Registered port, this port you have to register them from a well-known vendor. TCP and UDP use source and destination port to keep track of application conversation. This source port number is associated with originating application on the local device. The destination port number is associated with the destination application on the remote device. These are not physical ports, they are numbers that are used by TCP to identify this application and should be handled later. For example, HTTP, it has port 80. You have Telnet, port 23, SSH, port 22. These are well-known ports, and they are ports in networking devices, in networking concepts. WLAN protocols, wireless LAN protocol. WLAN stands for wireless local area network. A WLAN is a local area network using wireless connectivity. Wireless connectivity entails the use of high-frequency radio waves, which are transmitted through an access point. An access point is a hardware device that is used to propagate wireless signal. For example, think of a large fountain with a single spot access point. As long as you stay within a certain distance of the center of a spot coverage distance, you will always get maintain signal connection. The same is true for wireless access point. The access point allows you to connect devices within a certain coverage area to maintain a network connection while in operation. Access points are devices that extend wireless signals. For example, you have two buildings. The access point that covers more than 100 kilometers. There are others that covers less than 100 kilometers of range. And there are outdoor access points also that can go for more than even a kilometers. All those is to extend the range of the wireless access point and wireless access. For example, if you are in a certain building and you are not reaching and you are not having wireless access from the main wireless access point, you can connect a different wireless access point. Connect them even using, you can use cable, or you can break them so that they can connect together, so that the one can pick signal from the other wireless and give access to that new access point. The institute that is responsible for the standard for wireless access point, that is the IEEE, the Institute of Electrical and Electronic Engineers, for which we are specified in 802.11 collective group of standard that specify the radio frequency, speed, and other capabilities of wireless local area network. 802.11a, 802.11b, and 802.11g standard should be considered a legacy. New where WLAN should implement 802.11ac devices. Bluetooth, NFS, and RFID. Wireless protocols for close proximity connectivity include Bluetooth, radio frequency identification, and near field communication. Bluetooth is a wireless technology standard used for exchanging data between fixed mobile devices over short distances. and UHF radio and using a UHF radio wave in industrial, scientific, and radio band for 2.402 gigahertz and 2.480 gigahertz and building personal area network. NFS uses frequency 13.56 and is a set of RFID standard. NFS is designed to be secure method for computer transaction. Just like I said, Bluetooth, you can use Bluetooth to connect to your Bluetooth devices, exchange music, audio, transfer files, small, not a heavy file, just small files, or connect to your radio and the music. ZBEE and Z-Wave. ZBEE operates in 2.4 gigahertz compared to 908 megahertz of Z-Wave. The higher frequency allows ZigBee to transmit more data but reduce the range of signal. The lower range is reduced even more when there are obstacles. A higher frequency signal will travel through obstructions such as wall, less efficiency than low frequency signal. That is, ZigBee used to create personal area network with small, low power digital radio such as home automation. A Z-wave signal between two nodes can travel up to 330 feet in and outdoor obstructed settings. However, it gets significantly reduced in the hood, wall, and other obstruction combined with various source and electrical interference to reduce the effective distance. A more accurate guideline for in-home installation is 100 feet for no obstruction and 50 feet all in between. Cellular generation. These are the generation of mobile phones. The early generation of cellular, we started with 1 and 2G. 1 and 2G generation of cell phone was only for voice call only. 1G was integrated to 2G with digital voice, conference call, and caller ID. It has a speed of 9.6 kbps. An upgrade of 2.5 gigahertz, which support web browsing, short audio and video clip, games, and download of apps and ringing tunes. It can also go a speed of 237 kbps. The 3G generation can support full motion video, streaming music, 3D gaming, and faster web browsing. It can also go up to 2 megs of speed. Upgraded 3.5G. 3.5G can support high quality streaming, high quality video conferencing, voice over IP, and it can go to a speed of 16 megabits. The 4G network support IP-based voice, high quality streaming, multimedia. IP version 6 can go up to a speed of 672 megs. LTE long-term evolution. It is a designated 4G technology that with the 4G speed standard. It can go up to 1 gigabyte of speed. The fifth generation was ratified in June 2018 and currently being implemented in selected markets. It has a wide variety of apps that is augmented reality, AR, virtual reality, VR, small home and smart homes, smart cars. The speed can go up to 1.5 gigabit. Network services. In computer networking, a network service is an application running the network application layer and above that provide data storage, manipulation, presentation, communication, and other capability, which is often implemented using a client-server peer-to-peer based on application layer. This we explained in the previous slides. Client-server roles. Client-server model is a distributed application structure that partitions tasks or workload between providers of resources or services called servers and services requested called clients. Often, client and servers communicate over a computer network on a separate hardware, but both client and server may reside in the same system. Server hosts run on or more server programs which share their resources with clients. A client does not share any of its resources, but it requests content or services from a server. Client therefore initiate communication session with server which await incoming requests. Example of a computer application that uses client-server model are email, network sharing, and World Wide Web. The previous chapter we were trying to say that in a client and server-based system, a client always requests information from the server or fetch information from the server to get what it needs so that the end user can use it. For example, this is a web server, it is a file server, web server, email server. All these servers run applications. The web server, you use it to fetch information to get to the internet. The file server, you use it to get information stored on the file so that you can get it. Email server, you use it to fetch information like retrieving your email. So this client to get information from the file server, there must be a connection between the client and the server. This is a switch. Switch used to this switch is used for switching. For example, this computer to connect to this server, in this scenario, there must be at least a router. But also this switch can do the functioning, but there must be an IP address configured between this client server, a file client, and the web server, so that this client can fetch information from the server. The web client can also get information from the web server, and the email client can also can fetch email from the email server. And if if this client want to get files from this here, access the web and email, there must be a router in between that can do the routing. DHCP, Dynamic Host Control Protocol, and DNS. Dynamic Host Control Protocol, DHCP, is a network management protocol used on Internet Protocol network, whereby DHCP server dynamically assign an IP address and other network configure parameters to each device on the network so that they can communicate with each other over the network. DHCP, instead of DHCP assign IP address automatically on clients, you have a DHCP server that will do the assigning of the IP address. Once a client connect to the network, it will pick IP address automatically from the DHCP server. This is very important and very advantageous in a very large network. Instead of going from each PC assigning IP address automatically, the client will just pick IP address from the server and assign to itself automatically. DNS server, domain name service, is a method the computer used to translate domain name into IP address. On the internet, domain names such as www.cisco.com are much easier for people to understand than this IP address, which is a actual numeric IP address for this server. If Cisco decide to change the numeric IP address of Cisco of www.cisco.com, it is transparent to the user because the domain name remains the same. The new address is simply linked to the existing domain name and connectivity maintained. In this case, computers don't know text. All they know is numbers. But human being will understand text than numbers. It is very easy to capture www.cisco.com than 198.133.219.25. So it's very confusing. Not everybody can understand that. So instead of typing this thing on the web browser, you just type www.cisco.com, and when it reaches the DNS server, the DNS server will translate this thing to this. Will translate this cisco.com to this IP address, so that because the internet understand this thing, the IP address, not this thing. So it will convert this www.cisco.com, this IP address, and it will translate it and bring the cisco.com website, so that human being can also read it in text format, but not in numeric format. Printers and file servers. Printer servers enable multiple computers users to access a single printer. A print server has three functions: provide client access to print process, administer print job by storing them in a queue until the print device is ready for them, and then feeding or pulling the print information to the printer, provide feedback. Printer server are very important. Instead of, if you have an office of 10 people, instead of buying printer for everyone, you can just get one large big printer and make it a network printer, so that anybody can print from his or her office. Just send your print a network printer. Printer will be configured with IP address, and so that everybody can access it from his or her end device. Once your computer is configured with the printer and the IP address, you can print from anywhere in the office. Very advantageous before buying 10 different printers. Just a waste of money. File server is a central server in a computer network that provides file system, or at least part of file system, to connected client. File server therefore offer user a central storage for file and internal data media, which is accessible to all authorized clients. Here, the server administrator defines strict rules regarding which user have which access right. File server, you can have a file server so that staffs can fetch information from the server and store information in the server. And you can, anything you want to share on the network, you can put it on the file server, so that people can go and copy it from the server and have it to their computer, instead of using pen drive or hard drive to put it from one computer to another, which can bring virus to the network. And in file server also, their restriction is always there. You can put a restriction that people can only copy, upload, and download, but they cannot modify. So all those restrictions can be possible by the administrator. Web server and mail server. A web server is a server software or hardware dedicated to running this software that can satisfy client requests on a World Wide Web. A World Wide Web server is general contain one or more websites. Web server process incoming network requests over HTTP, several other related protocols. Web server are servers to access the web browser. For example, if you want to access google.com from your computer, know that google.com is a server. The server is located either at the cloud or is a physical server, but it's a server. But once you type www.google.com and you're on the internet, it will fetch it from the server and bring it to your computer. And your computer, you can do anything you want. But remember, it's always a server that you are fetching the information from. Email client. Email client communicate with email server to send and receive email. Mail server communicate with each other mail server to transfer message from one domain to another. An email client does not communicate directly with another email client when sending an email. Instead, both clients rely on mail server to transfer message, just like this server. Email also, there is always a server for an email. Once you are in your computer, you open your browser, go to any webmail you are using, either official or open-based, Hotmail, MSN, Gmail, Yahoo. All those mails they have their own mail server. Once you type www.gmail.com, it fetches it from a server. You type your username and password, it authenticates you. You have your information. Proxy server and authentication server. A proxy server is a computer system or router that functions as a relay between client and server. It helps prevent an attacker from invading a private network and is one of several tools used to build a firewall. The word proxy means the act on behalf of another, and a proxy server act on behalf of another. Proxy servers are servers that can be used as firewall in small networks. For example, if you have an office of 15 people, you can have a server and configure it as a proxy server. In that proxy server, you can do many restrictions. You can, in the proxy server, you can do a setup like staff should not access like Facebook from certain time to certain time. You can block many services from your staff depending on what you want them to access and what you don't want them to access. Proxy server can do that for you. Authentication server. Access to network devices is typically controlled through authentication, authorization, and accounting services, referred to as the AAAs. These services provide the primary framework to set up access control of a network device. AAA is a way to control who is permitted to access network authentication, what they can do while they are authorized, and track what action they perform while accessing the network. That's accounting. That's the AAA. Authorization, authentication, and accounting. The accounting, what the accounting will do is the way to control and permit access to the network. For you to access the network, you must be authenticated. For example, an ISP, like an ISP providing internet service for customers. Each customer is given an authentication so that you can authenticate so that you can use the services. If you don't pay, you are not authenticated. If you are not authenticated, you cannot use the service. The authorization, you must, in every network, you must be authorized so that you can have access to the devices. For example, in a data center, if you don't have authorization or a key to access the data center, there is no way you can access the data center and do anything in the data center. And accounting, in every network, there must be an accounting. Once you access the data center, You authenticate yourself, you are accounted, you are logged. Anytime they look at the server, they will know that certain Ali come to the server and he was authorized and he was accounted. So it's very important in every networking, the triple S. System log. System log protocol, slog, is a way network devices can use a standard message format to communicate with log servers. It was designed specifically to make it easy to monitor network device. Devices can use system log agent to send out notification message under a wide range of specific conditions. It is very important in every network. In every network, there must be a log in case of any problem. You just go to the logs, analyze it, and know exactly what was happening. Anyone who log into the server, the system should log it. If I log into the server and do something bad there, the system will log it. Once the system logs it, if there's any problem, the administrator can just come to the logs and know that yes, Ali log into the server, Ali did this, Ali did that. So it's very important in every network and in every server to have a system log. Thank you very much. That was the end of the presentation. Assalamu alaikum wa rahmatullahi wa barakatuh.